We now switch gears and talk about word problems. Okay, but as long as you understand for a vector, when we talk about the speed, you're finding magnitude. Vector, you write the horizontal component with the vertical component. Direction, I have to have two things. I have to have my degree and I have to have my direction. Okay? As long as you understand that, word problems are just fine. We have to make sure we know how to draw these. Okay? So these are not the same problem. These are three separate problems. So if I ask you to draw in a coordinate plane a speedboat traveling north at 30 miles per hour, where am I going to start? 0, 0. You're going to start on the origin. And then if my boat is traveling north 30 miles per hour, let's go by 10s, how many boxes are you going to go? 3. And am I going to go up, down, left, or right? You're going to go up. There's your speedboat traveling north 30 miles per hour. And then what if I come across a wind that's coming from the west 10 miles per hour? How do I draw that then? I go one box to the right. I go to the east. So I'd be there. Why would I not draw it to the left? Very good, because it says it's coming from the west. Okay, then switching gears, a river flowing east at 2 miles per hour. I draw it. Right, because it's flowing east, you're going to the right. So it'd be here, 2 miles per hour, if we're going by 10. Make sense? How we draw these? Okay. Word problem time. A jet is flying northeast at about 707 miles per hour. Its velocity is represented by the vector v, which is 500, 500. The jet encounters a wind that's blowing from the west at 100 miles per hour. The wind velocity is now represented by the u vector, 100, 0. We're going to find the jet's new velocity vector, the actual speed, and the direction relative to east. So you got to draw this. So what you're going to do, I'm going to go by 100. So I'm going to go 500, 500, and that's going to be my jet, right? Right? Yes or no? All right. So please be drawing this. There's your jet. Okay, and when he gets to that spot, that 500, 500, you come across some wind, and it's coming from the west. 100, 0 is that vector. So where am I going to draw that? You're going to go to the right. How many boxes? 1, because I'm going by 100. Alright, so now if I want to find the new vector, where do I draw that arrow? Where am I going to draw that? Where's your new vector? Right, it's from the origin to your new spot. And clearly I don't have straight lines, so I'm overlapping a little bit. But you're basically adding vectors graphically, right? The red to the blue, initial to terminal. So yesterday when we did this, that formed a new vector. Okay, so that's our green one. So what is that vector in component form? Say it louder. 600, 500. How many CY? My new vector is 600, 500. Because you're going along the x-axis, 600, and you're going along the y-axis, 500. Is Everybody see that? Okay? So now, I've got to figure out what my speed is. What do I calculate when I figure out what the speed is? The magnitude. So I take 600 squared plus 500 squared, that is equal to c squared, and what do I get? What do I get for c? Okay, now square root. 781.0. What is my unit there? Miles per hour. All right. So now we've figured out what the magnitude is, what the speed is. Please write this down. Now, I've got to find direction. How do I find direction? What two things do I need? I need the angle and I need direction. So, looking at our picture, I got a lot of things happening, right? I got the red, the blue, the green, and the black. What am I actually going to find the angle of? Okay, you're going to look at the green, and what angle it forms with what? The red or the black or the blue? The black. So you're looking right here in this triangle. Does it matter what trig function you use? Does it matter? It doesn't matter. You have all three. I don't care which one you use. So I heard tangent. So tangent of A, or whatever letter you want to put there, is equal to 500 over 600. So A is equal to the inverse tangent of that decimal. Round to the nearest tenth of a degree. What do we get? 39.8 degrees. And this is going to look a little different than what we did yesterday. You kind of saw it on the homework. The book writes it differently. So they say 39.8 degrees north of east. Or relative to east. That's what we're saying. And it makes sense, right? Because we're traveling pretty much northeast, right? So I'm up here, so I'm up at my north, and then I'm going east, right? That's all that they're saying, north of east. Does that make sense? Okay, so they kind of switched gears from yesterday to today on how they write it. But logically, it makes sense. All right. Any questions on this one? All right, do this one on your own. So now we're talking about a motorboat that's heading due east. What does due east mean? Straight east. Across the river at a speed of 10 miles per hour. The current of the river is flowing due north, so straight north, at a speed of 2 miles per hour. Sketch the two vectors on the graph and find the following. The boat's new velocity vector, the actual speed of the boat, and then the direction of the boat relative to north. So they switched that a little bit on you. So do this one. Okay, so you graph this. I'm going to go by twos. So my boat is heading due east across the river at a speed of 10 miles an hour. So I have 2, 4, 6, 8, 10. I'm traveling straight east. Okay? Then it encounters your river that's going 2 miles an hour. Okay, so what is your new vector here? Okay, so in component form you write 10, comma 2, and how do I draw it? From the origin to, okay, the green, yes, you gotta give me technical terms. The terminal point of the green vector. All right, so there's your new vector. Now, what is the actual speed of that boat? 10.2 miles per hour. How many got that? Okay, and all we did was 10 squared plus 2 squared is equal to 2 squared, and then added and square rooted, right? Perfect. All right, now direction. You're looking at this angle, correct? Okay, so sine, cosine, and tangent, I don't care which one you do. What do we get for the direction? I heard 11.3 degrees. Is that what we got? Okay. And what do we say for relative to north? Where is it at? Okay, yes, it's relative to east, but where is it now? Where are we going? You're going north of east. Yeah, it's north of east now. So we're just switching gears from yesterday. Yeah. Yep, that's all you have to say. Not anymore with these word problems. Not anymore. Not with the word problems. Because now you gotta be specific of, alright, you're heading up here, you're going up, and you're still going to the east. So. Usually. Alright, any questions on the word problems? Make sense? Pretty easy? The only thing to remember is your new vector is from where the very initial point starts, and then the final terminal point, okay? And then when you draw in your angle, it's always from what to what? For your angle. Well, it's not always going to be the x-axis, but it will be the horizontal line. And it's in between the horizontal line and what? And the vector. Okay? So it's basically an angle of elevation or an angle of depression. Okay? Good? Alright, so we have a worksheet for homework.